Hi, in this video we will learn about the graph of exponential functions, how they look like, and how we can use transformations of these functions, these graphs, to find a sketch of graph of more general functions. Okay, so to start with, let me just recall that when we say exponential function, we mean a function of the form b to the power x, where b, the base, is a positive number. Well, I will work on one example to the power x, and you will see how this example will give us an idea in general how the graph of the function b to the power x look like. Well, to find the graph of function, we need basically evaluation of the function at different points. For example, at 0, this is 2 to the power 0, it is 1. At 1, this is 2 to the power 1, this is 2. At 2, this is 2 to the power 2 and 4. And right away you notice that when we're trying to evaluate function in higher values of x, then basically we are putting higher exponent for 2 and we get larger values. So as the value of x increases, value of y also increases. Well, let me just plug in a few more numbers, but this time I will do the negative numbers. So f at negative 1 is 2 to the power negative 1, which is 1 over 2. This is 0.5. While negative power of 2 is smaller than 1. And when you do more negative numbers, you get 2 to the power 2, which is 1 over 4. And this is 0.25. Yes. And f at negative 3 is 1 over 8, which is what? 1 over 0.25, yes, 0.125. And as you can see, when the values of x gets negative and more negative numbers, we get smaller and smaller numbers. All of them are positive, but they get closer and closer to 0. So if I want to try to do sketch the graph, so basically I need to put up these points here on the graph, on the these coordinates. Let me do the red dots. So 0, 1. At 1, this is 2. At 2, it is 4 actually. And for 8, I don't have enough space to do that one. But what about negative 1? Well, negative 1 goes half. At negative 2, it goes half of that. So 0.25. At negative 3, even less than that. And if I connect these dots, I see that the graph of this function should look like something like this. Remember here the point that I mentioned, when we go to the negative numbers, the graph of the function gets closer and closer to the 0 here, y equal to 0 line. Very nice. So that is a sketch of the graph 2 to the power x. Let me do one more example here before we look for the general trend, or how in general the graph of the function, exponential function, look like. Well, this time I will do this 0.5 to the power x. Well, at this stage, I suggest you pause the video and try to find the some points of this this function, and as we did in the example 2 to the power x, you do find some points and then try to connect them and sketch the graph of the function. I will do a different method to find the graph of 0.5 to the power x, but you can do the evaluating at different points. Well, okay, how I'm going to do this one. So this is an example. Don't take that as -1. So here what happens is that I can see that 0.5 is 1 over 2 to the power x. Yes. And then remember, always we can switch this, flip this, but we have to write the -1. 2 to the power -x. So f of x, which was 0.5 to the power x, is basically the same thing as 2 to the power -x. But remember that the graph of such a function, basically this is obtained from 2 to the power x by switching x to -x. Yes. Means that the graph of 2 to the power -x is obtained from the graph of 2 to the power x after the transformation. You should know that when you turn x to -x, basically the transformation we are doing is reflection about y-axis. So we can find the graph of that one by reflecting about the graph of 2 to the power x about y-axis. So let me just do copy paste this one and try to paste. Unfortunately, I don't have the right tool to use the reflection here, but I can do just try by doing by hand. So here I'm reflecting with about the y-axis. This is the axis of reflection. So this piece will come something like that, and then that's the reflection. So we reflected this guy about the x-axis. Y-axis is almost what we have. And let me just delete the previous one. And as you can see now, we are having a little bit different graph. This time, the graph of function gets closer to 0 as the values of x increases, and it goes to infinity as the values of x decreases. Yeah. So this means what? This means that we are going to deal at least with 2 different versions. And what is important here is to see the difference of bases. Base for this function was 0.5, and for this function was 2. One of them is bigger than 1, the other one is less than 1. And in general, this is what we will see in general. The graph of function f of x f of x equal to b to the power x will have actually 3 possibilities. When b is bigger than 1, when b is less than 1, well, we assume always that b is positive, or when b is equal to 1. So these 3 three cases. For b equal to bigger than 1, well, we had one example up there. It will be an increasing function, something like this, and then gets closer. For b less than 1, we are going to have a function which is basically mirror picture of the other one with respect to y-axis. So it will give us a decreasing function. For b equal to 1, when you see when the constant is, the base is constant b1 to the power any number is going to be 1. So it will give us a constant function 1. Well, this is why sometimes in some books they exclude b equal to 1 to be our base, possible base for exponential function, but we have it here, and you will see later that we have to exclude at some point this case. So we have these three cases, and there are a few remarks that I want to add. First of all, y equal to 0 is what is called horizontal asymptote, is a horizontal asymptote. We will get back to this later in the course, but what you need to know at this stage is that the values of the function gets closer to y equal to 0 when b is a number less than other than 1. The other thing that to note is that look at the values of the function. In other words, the y values, all of them are positive numbers. The same goes with the case that b is less than 1. So it means what? It means that we can look at this function and say what is the range of exponential function. So range of b to the power x, again we are excluding 1, is all the positive values. In other words, it is 0 to plus infinity. And very last thing, all graphs passes through 0, 1. So this is 0, 1 here, 0, 1 here, 0, 1. That's simply because f of 0, no matter what is b to the power 0, which is 1. So these three things we have to keep in mind when we work with the graph of exponential functions. Well, how we can use these ones and transformations of these ones to find graph of a little bit more general functions. Let me do an example here for you. Example. Sketch the graph of function f of x equals to 2 times 3 to the power x minus 1 plus 1 here. Okay, so remember the transformations we can do on the graph of functions. So if I start with 3 to the power x, then I can go to 3 to the power x minus 1 by switching x to x minus 1. Then the next step, I can add 1 to the whole function. So basically switch the function f of x to f of x plus 1. And then at the end, the last step is when we multiply the whole function by 3. What we have in hand by 2, sorry. So 2 times f of x. We know that each one of these operations I'm writing up there gives us a transformation of the graph, and we will try to follow those steps and find the graph of the function. What does turning x to x minus 1 do? It basically, what does it do is that you have a horizontal shift to write 1 unit. So let me just write it. So horizontal shift 1 unit to the right. Well, it means what? It means that if I know the graph of 3 to the power x, 3 is bigger than 1, so it will have a graph like that, yes? I can then find the graph of 3 to the power x minus 1 by, let me copy this, by simply okay, I missed that part. Okay, simply by shifting everything 1 unit to the right. So if this is almost 1 unit, and then I will do this one. That's what we have there. So we found the sketch of this new one by shifting everything 1 unit to the right. How about this other one, f of x, which is 3 to the power x minus 1 plus 1. So when you add the whole function 1 unit, it means that we are doing vertical shift 1 unit upward. 1 unit upward. So it means that if I select this guy here, copy and paste, I'm dealing with this. Let me just sketch it down here. I am now dealing with this case that we are shifting everything 1 unit up. My function is not one piece, that's why I have to do everything in 2 units, 2 steps. And then at the last step, this is an interesting step, at last step, we multiply the whole function by 2. So that means that that operation is a vertical stretch two units by factor of 2, sorry, by factor of 2. It means that everything will be multiplied by 2. So let me draw another one here, because that one was a little bit reshifted, 1 to the right, 1 to the up. So it will be something like this and this, like that. Okay, now I want to shift this, stretch this by factor of 2 vertically upwards. So let me just make enough space for that, and then to perform the stretching, I need to do this trick that I keep one point on the x-axis, and then you stretch everything by unit of 2. So you see here is 1, 2, 3, 4, 5, 6. I have to upward up to somehow 12. Yes, it is kind of, yeah. So this is the new function, the graph of the function given in the example. Well, to make sure that we have track of everything here, so this line y equal to 0, the asymptotic, the horizontal asymptote, well, by shifting to right stays the same, y equals to 0. And by shifting it upward 1 unit, this will move to y equals to 1. And then by shifting it, by stretching it by factor of 2, it will move to y equal to 2. It's a little bit higher than what we have. Also, the 0.01 here, by shifting to right, goes to 1, 1. By shifting 1 up, so this will be 1, 2. And then by stretching up, it will go to somehow 1, 4. Kind of shows itself here. And an important and nice thing that you can use from the sketch of this graph is that now you see this new function, the function we have, all the values of that will be above this line. So as we did before, this guy's here and then here, all of them are about this line. So it means that then range, note that the range of f of x equals to 2 times 3x minus 1 plus 1 is, well, everything above the line 2, so 2 plus infinity. Well, you have to be able to do more examples of transformation, but this basically gives us a flavor of what we need to know. An important thing was the graph of the exponential function for different bases, and you have to be able to perform and read information from the graph.